I'm going to hopefully only have to say all these things once, so I hope you can hear me. Now, we're going to talk about angle measures today. A protractor measures angles from the end, and it ticks up like this. Yeah? Yeah. Okay. This is like 10 degrees, whatever. What's this? Okay, what's this? Beautiful. Now, a protractor only has 180 degrees in it. We have a new type of angle that is that's not in degrees. Now, degrees are a little bit made up. They're called radians. Have you guys heard of a radian before? Yes. Oh, you have? Can anyone describe to me what one is, though? Or where the word comes from? Radius. Oh. So, when we talk about a circle, and in this case a half circle, we're going to start counting something called a radian. So on your paper, could you please draw just like a little half circle? Oh no, I messed up. Because they suck. I'm not kidding, they're a menace. Sorry, now that's on camera. Okay. Shh. Okay. So first thing you guys need to know is we always actually count from right here as our 0. So we're going to label that this is 0 degrees. And that means on your protractor it counts upward. What is this degrees? Beautiful. What is all the way around? 180. Beautiful. And now maybe I'll just cut it into quarters. Bang and bang. What goes there? What goes there? 135. Nice. Okay. So notice that I cut my 180 into quarters. Now, a radius, here's the thing that I find out every year for Pi Day. You guys don't know what pi actually is? It's a food. It's the ratio of the circumference. Great. So, it just so happens. Okay, did you guys know the reason 3.14159 whatever is special is that that's how many times that a diameter fits around the outside of a circle? If you have a circle and you take the diameter of that circle, like if you stretch a string across it, let's pretend you stretch a string across the circle and cut it, that string will fit around the outside 1, 2, 3.14159 times. Every time.
Oh, and then half I seen the little, you know, the spirally thing that like goes in. I seen that. Yeah.
So, this is true for every circle. A long time ago, someone discovered this. It's beautiful. Math is discoverable. If you took a string and stretched it across the earth and cut it, it would fit around the earth how many times? 3.14159 times. Model. So, for a radius, that actually means that how many, there's pi diameters around the outside. How many radii fit in half of a circle?
1. 1.5.
No, it's pi. Let me draw it for you. So, let's go over here. It's not special. This is where the word radian comes from. So, can you please label this R? Shh. It turns out that this radius fits around the outside 1 time, 2 times, a little bit more than 3 times. It fits around pi times. So, a radian measures the angle that it would take to get to 1 radius. So I'm going to do this. This to me, this is an acute angle. I don't know, in degrees, like 50 degrees or something. It doesn't matter degrees anymore. This is 1 radian. This angle is 1 radian big. You're not used to measuring things in bigness of radians, but that's 1 radian big. That means that if you guys drew an angle down here, that obtuse angle is like 2 radians big.
Wait, what do you mean 2? It's gonna be maybe like 2 something.
Well, this is pi now. It's okay if this isn't making sense to you because most students are never actually taught where this comes from because we only really care about degrees. And so we translate degrees into radians and back and forth. We don't really use whole numbers of radians. But do you see where we're going with this? Okay. Now, underneath here is the most important half circle we're going to get. I have to get rid of this. Do you have another color or a highlighter?
I have black.
I wish I did.
No.
I wish I had a highlighter. I really wish I had a highlighter.
Okay. I'm going to draw the exact same half circle, but now I'm going to tell you. Shh. Now I'm going to tell you that this is now pi number of radians. This is 0 radians.
She said a bad word.
And all the way over here is pi radians. That means there's 3.14159 of them or whatever. And so from now on, we don't care about whole numbered radians. We care about the fraction of the whole. So I'm going to cut this into quarters. And from now on, we are just going to say, if I cut this in half, this isn't 90 degrees anymore. This is 1/2 of pi radians.
Why can't you say 1.5 radians?
You don't use decimals.
Shh.
Please just write this down and stop talking. Stop talking. You're never going to see 90 degrees. You're going to see maybe 1/2 of a pi radians. It seems awful, but that is 1/2. In that case, what is this little piece? It's 1/4 radians. It's 1/4 pi. Now, there's not a nice little symbol, so we have to write the word radians. I like that degrees has just a little marking, radians doesn't. If that's 1/4 and that's 1/2, what's this? It's 3/4 pi radians. Great.
No, because then what if people confuse it with day?
Yeah.
Why does it calculator?
It's a mode? Calculator mode?
Yeah. No. Sorry.
I don't know if this is exactly right, but it starts over here because on a coordinate plane, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. The same way it goes 1, 2, 3, 4, we go around counterclockwise. Great question. Yeah.
So like, if you put tan 30 in rad mode, would it do tan 30 radicals? I mean radians?
It would do the tangent of 30 radians,
Wow.
which is not at all 30 degrees. 30 radians would be, I went around the circle a bunch of times,
That's a lot of
and the
degrees.
angle would be huge or something like that. Great question. That's why your calculator mode needs to be either degrees or radians.
Oh, that makes sense with degrees.
Any other questions? Thank you. What's up? What did I do? Phone charger or computer charger?
That's pi radian. Right.
Yeah. Are you in class?
Pi radian.
Question.
It's 0 to 180 degrees is the same as 0 radians and pi radian.
I only have it plugged in, so you'd have to leave it.
Oh, right here is 1
Which
radian.
phone?
Right here is 1 radian. Right here is 1 radian.
How's it been?
Back of your 2 phones. Good. I'll leave it right there.
Maybe right here. Here you go.
Okay, sorry for the disruption. Sorry, Josiah, what's your question? No, that's a great question. Okay. Perfect. Hey guys. Great question. The question is, this is only half of the circle, so the bottom isn't negative. Instead, it's more than 1. So, if this is 1 quarter, 2 quarters, 3 quarters, 4 quarters as a whole, this is 5 quarters. 5 quarters pi. And it goes more than 1. So 5 quarters, 6 quarters, 7 quarters, and then 8 quarters. Yeah?
Does that mean that at the 0 pi radius?
It means that when you go all the way around the horn, this is 2 pi total. We have 1 pi on top and 2 pi on the bottom. And I really hope that you didn't get that question answered already by the person sitting next to you. Yes?
Why do you cut it in quarters and not 8?
You do not just cut it in quarters. Great question. That's a great question. We are also going to cut it into 6. Could everybody please move down on your page? We are now going to cut one into 6.
Why is it not 8? I don't understand.
Hang on 1 second. No. To cut my pi into 6, I need to cut it in half, and then I need 3 pieces on each side. Please don't be a silly dummy. And make sure you cut into nice 1, 2, 3 on each side. That is 6ths. You have a straight edge on your protractor if you'd like to use it as a ruler. All right, if I cut this into 6, can everyone please help me? How many radians is this? It's 1/6 of the pi. Now, you guys are actually never going to see 1/6 pi. You're going to see it simplified as pi divided by 6, which is pi over 6. That's fine. This is 1/6. Now, this is 2/6, but 2/6 can be reduced. So this is actually 1/3 pi radians. 1/6, 2/6, and then 3/6 is actually still just half of pi. Three-sixths, 4/6 can be reduced. 4 over 6 is 2/3 pi radians. 1, 2, 3, 4, 5, 6 is the last one that cannot be reduced. And then 6/6 is a whole. So, Naeem's got it. The whole unit circle will have, after 5, 6, 6, 6, it's going to have 7/6 over here. And then it's going to have 8/6, 9/6, but that's reducible. That's 1.5. I just wanted you to do the top of it today, just so we have an idea of it. Yes. Oh, Marcus, did you have a question? Oh, okay. Are there any other questions before I tell you why maybe this is relevant?
Yeah, no.
What is the outer
Yes, we're getting that. So, the outside of the circle is actually the answer to sine and cosine. So when you're trying to find the sine of 30 degrees, you go to 30 degrees and you look at that coordinate point and it gives you the sine and the cosine. We haven't learned why that's helpful because that's the next part, but the first thing is just knowing what's the same as what. 30 degrees, believe it or not, 30 degrees is 1/6 pi radians. You should write this down.
Wow.
Maybe like 2.
90 degrees is
I think the bottom number is just like
159. She's photomapping.
No, I'm trying to record it, but it hasn't been facing the board, so they won't feel it. And whatever. I don't know if I'm gonna post this. 90 degrees is 1/2 of a pi radians, which is usually just written as pi over 2 radians. That's half of a pi. Okay, don't freak out.
So 360 is just 1.
If you are asked, never mind, this might freak you out.
What?
Never mind. If you're asked what 32 degrees is, you can still find it, but it's not on the unit circle, so I'm not going to freak you out. The next part is more important. Are you ready? Yes. Underneath here, I would like you guys. 1 degree. Whatever pi divided by 360 is. Pi over 360 radians.
32 degrees would be.
Yeah, I'll do it right now.
All right.
Oh my god.
I need you guys totally with me here. Let's imagine for a second. Yeah, that's not helpful. Let's imagine for a second you're on a Ferris wheel. Let's say that this Ferris wheel let's say that there's stairs to get up to this Ferris wheel. And there's a little gondola there for you to step into. And the gondola that you step into is already 5 meters off the ground. Now let's say that this entire Ferris wheel goes all the way, it's 20 meters from top to bottom. I have some quick questions for you. Now, in another color maybe, I'm going to start by labeling the onboarding position, position 1. When you're in position 1, how high, this is a great question. The question is, how high are you? Yes, nothing like it.
What?
Shh. How high? Hi, Min, I'm teaching. Sorry. Nice to talk to you. How high are you if you're at position 1?
5 meters.
Now, I'm going to label a position 2. You're at the very top. You're at position 2. You're at the very top. How high are you?
25 meters.
Oh, thank you guys. And finally, if you are in the midway point, how high are you? No. You are 15 meters high off the ground. Okay. Now, here, stop talking. Here's the part that matters, is that these are easy for you to come up with because it's exactly half, or whatever. Now, when you're on a Ferris wheel and you start down here, you don't go off the ground very much. But as you go around the circle, you start raising higher faster. My question would be, in a position like this, how could you figure out how high off the ground you are?
By the pi radian.
Or maybe you're like really close. You're up here, you're really close to the top, and you're on step 4. How could you figure out how high off the ground you are? Because you're under 20, but do you know how much?
Something about radian.
You would need the angle. So, underneath here, you are going to draw a little diagram. this is why it's relevant, is it helps us measure things with trigonometry and geometry. Let's draw for a second.
New stuff. That's new. I'm so sorry.
We know that this part of the circle is a radius. How long is the radius of this circle?
I just drew a perfect circle.
10 meters high. So you have already surpassed
Oh, we're using the same circle.
the bottom half of the Ferris wheel. And now we're gonna say you're up here. Now I'm gonna label that you are at a 60-degree angle right here in position 4. Can you guys see from where you're sitting? Because I know I'm kind of low down.
Yes.
Okay.
I agree.
Your job is to find the height. Could you make a little dotted line, please? Dot, 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 dot to represent the height. And you go, oh shoot, that's a right triangle. So out here, we have a 60-degree angle and we're trying to figure out the height. That is our question mark. How high are you on this hypotenuse?
The hypotenuse is 10.
Can you stop?
Let other people think for a second. Let other people learn. Now, if you're trying to figure out how high this height is, you only have 60 degrees right now. You would need a little bit more information. Now, you know that that's 60 and that's 30, but do you know any of the other lengths of the triangle?
Hypotenuse is 10.
How do you know the hypotenuse is 10?
The radius of
Like yes.
Oh.
Because it's a radius.
I forgot about that.
That's 10, and that is also a radius. We're using our circle fact. That also is the radius. It's 10. And now you can use which formula?
30, 60, 90.
So 10
Sure,
is
I'm not going to do that. Maybe instead I'm going to use sine. Or you know that it's 5 root
5 square root of
3. That's 5 root 3. Or you could do sine of 60 is question mark over 10, and you could solve it like that.
I'm dreading the test.
They're not do the sign.
It's just sine 60 times 10. Sine 60 times 10 equals whatever.
That would give you the remaining height to tell you how high you are off of the ground.
Wait,
but that's not.
Robert, you wanted to do something, so can you use a unit circle instead of a calculator? Is that like the same? Is that the same or not?
The unit circle has the answer on it,
But it's kind of hard.
and you don't need a calculator. And the unit circle has memorized for you the 30, 60, 90, and 45, 45, 90. That's where they come from. So this is 5. This is 5 root 3. What is 5 root 3 as a decimal?
I don't know.
Great. That's how you find. That's how you find the height and how you use it.
It's 8.66.
It's great. It's not 10. It's 8.66.
Not a number, sorry.
All right. Any questions from students in my class or in other classes who are 2 days ahead of us?
Echo my head.
All right. You have homework due. The homework is in Google Classroom, or you can tear out pages 709 and 710 out of your book right now. Couldn't we do some cleaning up, please? I'll take the protractors in a pile. Let's put them in a pile so I will see. Pile them up right here so I can collect them all. Pass it down. Not even in my car. I was trying to think upside down. This might. The activities office might. You begged me.